Here we go. This is a review. I think the first time you might have seen exponent rules was actually in 7th grade. But we're going to do them again today. This is an exponent. B to the P. They have good soup there. What does it mean to have an exponent? It means you have that many numbers multiplied by each other. All right. Hold on a second. Yes, sir. It's a mugshot you got. All right. How do you calculate these on a calculator? Can you all do it? All right, this is the first homework question you're going to see is calculate these using a calculator. So what the biggest thing is, make sure, what button do you use on your calculator to get, what's it look like? It's a caret. Why is it called a caret? I have no idea. That doesn't look like a caret. That's 125. All right. Biggest thing I want you to recognize is this. When you're plugging these in a calculator, what do you have to do with this number? What do you have to do when you plug it in? You got to put that in parentheses. Why? It'll put the negative, right? So pay attention to that. You got to do it. Okay? Fractions. Reminder with fractions. What do I do with a fraction with a power? Where's that power go to? Like if I want to write the answer as a fraction. This is the same thing as 3 to the third. Negative 3 to the third over 5 to the third, right? When you have a fraction, they're both being taken to the third. Now, if you want decimal, just plug the whole thing in. You're fine. That's what? Negative 27 over 125. Okay? Can you even take pi to a power? Yeah. There we go. That's one of our homework questions. Sound good? Yeah. Pew, pew, pew. All right. What's another homework question going to look like, I wonder? We're going to need to know our exponent rules again. The reason we're going over this is they're going to come in. Everything we're going to be doing is going to be dealing with exponents this section. All right. You guys remember this rule from back in the day? If you're multiplying, you add your exponents because you never do the same operation twice. If I'm multiplying down here, I do not multiply up there. Okay? You never do the same operation twice. If you need a visual, if I have m b's times n b's, that's m plus n. Or the way I always show it is like if you have b to the 2 times b to the 3, you have 2 b's and 3 b's. So that's 5 b's. That's why it's adding. Sound good? You guys remember that? If not, you guys can blame your geometry teacher. That's fine. I always get blamed. Never mind. I'll save that joke for later. All right, how do I do this? What do I do with my exponents? X to the 5th times x to the 9th. Add them. That's x to the 14. What do I do when there's a lot of different letters and numbers? Start by doing, I'm going to go over here because what's 2 times 5? 10. Then I have x to the 3rd times x. So 3 plus 1 is 4. And then I do 6 plus 2 is 8. This is what homework question number 2 looks like. How's that seem? Okay. Let's do one more for fun. Negative 3 times 7 is negative 21. Add my exponents here. We get x to the 14. Oh no, there's no y. That's fine. It's fine. It can hang out by itself, like me in middle school. All right. Does that ring a bell? Anything too scary with this so far? All right, let's keep going. Oh no. So if I divide them, I subtract. Multiply, you add. Divide, you subtract, right? Again, the example I always use for this, if I have b to the 3 over b to the 2, that's 3b's over 2b's, which gives me 1b, right? Hopefully it doesn't sting me. It's been a long week, guys. All right. So if you like the reason, you can use that. Biggest thing is you're subtracting your exponents if you divide, because you're going to have less of them. They're canceling out. So let's do these two examples. We're tracking. All right, so what do I do with my exponents if I divide? You subtract them. Yar? 28. 828. Tomorrow. I'm canceling my second hour class just for you guys. All right. What's 12 over 8 reduced to? 3 over 2, right? Divide both by 4. Then what do I do with my exponents? Subtract them, right? 8 minus 2 is 6. And 4 minus 1 is 3. Should I have written this as well? Yeah, these are the same exact thing. Okay. We're almost done with 6.0. I have an IXL on these if you guys want it. What's anything to the 0 power? 1. What's 1,000 to a 0 power? 1. X, Y, Z to the 0? 1. All right. What do I do with a negative exponent? You flip it and it becomes positive. So I like, this rule is going to come up later, but I'll just give you a reminder. Like if I have x to the negative 4th times y over z to the negative 3, what can I do to make those all positive? What do I do with all the negatives? You flip them. Yeah. I can make any negative power positive. Just move it either from the top to the bottom or the z bottom to the z top. Z. All right. Can we do this? Maybe not. All right. Let's take a look at this one. Oh, no, that's the rule I just talked about. That's just restating what I said, that the negative flips them. All right, let's do these examples. You guys see, I was trying to be nice to you after this unit. I'll print you guys off 2 per page. You'll see in 6.1 that I'm going to give you guys a lot more space, and it should be easier to follow. All right. What do I do with all my negatives? Flip it. So I'm going to move it upstairs. Congrats. It doesn't have to live in the basement. What do I do with my negative exponents? The B comes upstairs, and the A is going to go downstairs, right? Because they're not happy with where they're living, so they got to make a change. And so when they make the change, they're happy again. They become positive. All right, here we go. All right, one more big rule, right? B to the m to the n. You multiply them because you're not multiplying down here, right? You're taking a power to a power, so you multiply your exponents. And that's because if I've b to the third to the square, how many groups of 3 do I have? I have 2 groups of 3 b's, which is 6 b's. So that's why the multiplication rule works. Okay. I know it sounds goofy, but this is the way that always helped me remember it. I thought of a really basic example of what's actually going on, and that reminded me, do I add my exponents or do I multiply my exponents? Okay. So this, it is goofy because they're bees and they sting you. Yep. Multiply them. All right. When a problem comes along, you must multiply it. We talked about this one briefly, but when you take something to a power and it's in parentheses, that power goes to everything in the parentheses. Okay, sometimes that's easier to do than the whole group. Same thing if they're a fraction, right? Fractions, both numbers get hit by the exponent. Okay. Best way to do that is with an example. So that exponent's on the outside parentheses, so everything gets hit by it. That's 5 to the 4th. I'm just going to write a to the 3rd to the 4th and b to the 4th, right? That 4 hits every piece, okay? 5 to the 4th is, what, 625, I think? Yeah. So I multiply those. 3 times 4 is 12. And b to the 4th is just b to the 4th.
Hey, Luke. Hey, Deacon. Hey, Sal.
All right. Dude, that's a lot of food for a little boy. Oh, am I? Delicious. Oh my gosh, that's good. It's a peach cobbler. All right, so that 3 has to hit every single piece, right? That 3 has to hit every single piece. So, what's negative 2 to the 3rd? And then we do, all right, we can keep it like this. We'll do this later. A to the negative 6 to the 3rd and b to the 4th to the 3rd. Do you have to write this? For some of you, for exponent rules, I don't write down all my steps because for some reason I get confused, or not confused. There's just a lot going on. I would just multiply all my exponents by 3 and rewrite it. Negative 2 to the 3rd is negative 8. Well, just negative 8. A to the negative 18, because I'm multiplying negative 6 by 3. And then b to the 12. Am I done? No, you can't have negative exponents. So this person's not happy with where they're living, so they got to move. They don't like the negative 8. They move downstairs with the b, and they're a lot happier. All right. Usually alphabetical, and that's exactly where